we will talk just about the foundations of machine learning, right? And since we're going to put this into kind of bite-sized capsules, it might be helpful. I'll talk about it for about 10 minutes, and then we'll have about 5 minutes of interaction. So it's kind of like the Coursera style, where I don't have really long recordings. So let's try to do like about a 10-minute segment, and then we take a break, discuss, and then do the next 10-minute segment, and so on, right? So in general, when we talk about machine learning, there might be different ways to do this classification, but let's talk about one way to do this classification: supervised, unsupervised, and reinforcement learning. Right? So how many of you have heard of reinforcement learning? Yeah, you can raise your hands. Okay. And another thing I want you to take away from this is, like, to get the most of this class, I'm going to always give you some keywords and stuff like that, right? So because this is a grad level class, my goal is to make you curious, right? So you go back and look up stuff and read some of this stuff, right? It's a 1-credit course, and my plan is, since you guys are my first cohort of this 1-credit course, I'll follow this up with a 2-credit course. And I was talking to Nate. Don't quote me on this, I'm being quoted, but but I think a nice way to make it count for you guys would be, this will be a 1-credit, and then I'll have a 2-credit. So that'll cover a 3-credit requirement, right? And once this gets a permanent course name, because this is the first time I'm offering a course, so I think 13 is a pretty good size for the first cohort. So once it gets permanent, it's going to count towards the data science stuff and everything. So we work on the paperwork and everything, right? So you should be covered, especially if you're starting off, right? I think the paperwork takes some doing. Okay, so supervised, unsupervised, and reinforcement learning. So a lot of this stuff, again, so let me throw out some keywords here. Labeled data sets, right? So a very commonly used data set is the data set from the Portland housing market. And I think, so again, with a show of hands, who knows about the Portland housing market, and who thinks this is super like easy? And okay, okay, you're willing to kind of, yeah, for the sake of everyone, let's just pretend no one knows about all this, right? So the Portland housing market is a very commonly used data set, and it's a very commonly used data set for supervised learning, right? So let's talk about supervised learning for the next few minutes, right? So when you give me the feedback, if you put your name, I'll know, like, if you already know some of this, if it's still being relevant, right? By way of telling you this, right? It might be different. You might have some idea that might be helpful to understand the full perspective. So what happens is, say you're kind of trying to predict the price of a house. Dollar price of a house, right? So what do you think would be the input that you have to put into the prediction process? Like, what are the things that would affect the final price of a house?
The square footage.
Yeah, so that's one common one. Any others? Location.
Number of bedrooms.
Number of bedrooms, number of bathrooms. So things like that, right? So those are your input features, right? So let's say square footage is one input feature, x1. Number of bedrooms is x2, number of bathrooms is x3, and say location is x4. So what we might have done is, I'm kind of thinking along the lines of a data analyst, right? So one of the things we want to do is, we don't want to have a huge number of features. So again, I'm kind of trying to tell you some stuff, take some stuff with a grain of salt, because I don't want to overwhelm you. So there is the sweet spot of the number of features, right? So if you have one feature, you might say, again, accuracy, I'm going to introduce these metrics later on, but you might say, as we keep increasing the number of features, the accuracy of the model keeps increasing. Do you think the statement is true or false? True? Yeah? Yeah? Okay. Anybody thinks this is possibly, like, there are nuances here? Let's make it pretty active. Like, it's fine if, you know, like, if you have, like, some...
When you say accuracy, you mean variance, or?
Yeah, let's not worry about, like, the nuances of the accuracy thing. Just overall. Do you think, as you keep increasing the number of features, the model will keep getting more and more accurate?
I think so, yeah.
Okay. So, yeah.
Yeah, I don't think so. I guess that has some point that has a plateau that the
You read this?
Yeah. Sorry.
You read this, or you just came up with it?
Yeah, I guess that in animal breeding, for
Okay.
example, when we are defining the model,
Good.
like
Yeah, good. Yeah, and one of the reasons I'm asking you these questions is, I want to see how much you already get the intuition, right? You're right. So just like anything else, there'll be a sweet spot, right? So if you think of the model accuracy, right? So it'll keep increasing, and then it might start dipping. Might not start dipping this way, but it might start doing this, right? So there will be a certain number where you'll have the maximum accuracy, and then there'll be some kind of a fall in the curve, in the plot, right? Now, one of the things that you want to do is, and again, I'm going to throw these words at you, and what I'll do is when I'm scribbling, I'm going to use a different color, and when I'm kind of giving you some keywords, I'll use a different color. If I can find one. Oh my gosh. Okay. Oh, wow, thank you. Okay. This is not super different, but hopefully you can see the brown and the red. Okay, thank you. Okay, so what I'll do is I'm going to throw, oh my gosh.
Try this one.
Okay, thank you. I'm told, like, when I'm being recorded, it's actually nice to be natural. So we'll just pretend nobody is recording us. So there is something called dimensionality reduction. This is actually more fun than just going through slides. So I'm going to try to do this a little, because sometimes what I do is when I have slides for lectures like this, I just pass through like 3 slides and I don't go any further because I keep talking. So we'll keep doing this for a while, and then we might switch to PowerPoint at some point. So dimensionality reduction is something that you do to kind of get to that sweet spot, right? The goal of dimensionality reduction is you try to prune the number of features to a point where you're getting maximum reward from that number of features. And when I say reward, it means the performance of the model. So I'm going to write that again, because these words, and these are actually helpful for me, these words will actually form the basis of many of my lectures. So model performance, remember somebody talked about accuracy, so there are many nuances of this model performance. And when these models, as they are designed, as machine learning models are getting more sophisticated, depending on what specific performance metric, I'm going to see these very clearly, and I might even be repetitive so that you get these words really well. So as you say, if you see things like, okay, here I'm going to throw these here, and you might go in and look, but we will talk about these in future classes. I don't want to super inundate you, but let's talk about 2 potential model performance metrics, precision and recall. I'm not going to dig deeper right now, but just to give you an example. So if in my specific use case, if I want to optimize my precision, if I want to maximize the precision metric of my model performance, then I might design my model in a certain way. Whereas if I want to maximize the recall metric for my model, I might go back and design my model in a certain other way. So this is kind of the latest machine learning research, where you're not just coming up with a model and then coming up with the final model performance metrics, but there is an iterative process where, depending on what is the particular performance metric that you're trying to maximize, you go in and have this feedback to the model to actually optimize that specific performance metric. Is that clear? So I covered a lot of stuff here. And I'm going to try to have these inbuilt pauses. So do you have any questions so far?
I guess I have a question.
Yeah.
When you're talking about accuracy, precision, and recall, I'm trying to, but these terms for me are kind of convoluted. I cannot tell them apart.
So don't worry about that. That's how I'm kind of giving you these keywords right now. We will have separate class lectures. Like, this is my only face-to-face time with you, so I'm kind of giving you like the lay of the land, right? Some of the important takeaways from this course, right? So there will be a big chunk of the lecture in this, because this, I feel like if I start drilling down into the different performance metrics, that is like a whole, like half an hour minimum lecture. Half an hour might also be speedy for it, right? So right now, just take my word for it that these are different model performance metrics. And that's actually a very important point, how precision and recall is different. And there are different times when I might want to increase the precision of my machine learning model, and there might be other times when I want to increase the recall of my machine learning model. But right now, don't worry about those nuances. We will cover that, right? And I'm putting them in green. That's like, some of the things that we will actually focus on. So those are my keywords. And you don't have to necessarily go and look at them right now, but by the time we're done with the course, you should have a good understanding of those, right? So those are important things to take away, right?
So a question, do we on recall, or can we have both at the same time?
That's a good question. So again, I like your questions. So there are ways in which you can integrate the two metrics, right? So if you don't have, for your specific use case, precision or recall, you don't have a preference for various reasons, we'll come to that. There are ways in which you can smush both the metrics into one metric and then optimize that, right? So we will talk about that as well. I just gave you two of the very popular examples of measuring the performance of a model, right? So here I've actually thrown in quite a good number of words, and since we have so many whiteboards today, I'm loving it. So what I'll do is I'm not going to erase this, right? After the break, we'll use a different whiteboard, right? And then we'll label the whiteboards, and we'll have like a nice lay of the land, right? Totally use our in-class, equipment and resources, right? So we actually totally went from this to here. But I think an important thing is machine learning overall doesn't matter what you're trying to do. There should be a way of being able to see how well your model is doing, right? So this is kind of at a higher granularity. You should be able to measure the performance of your model, right? Doesn't matter what is the kind of model, right? So this is like at a higher level, right? So now we're going to drill deeper, right? That will be a different class where we'll actually drill deeper into that. Because if you're not able to measure the performance of your model, you don't really know how well you've done, right? So that's actually a very important perspective. So we'll not rush into that right now. Okay, so again, coming back to just like the overall types of models. So I told you there is supervised, there is unsupervised, and there is reinforcement learning, right? If you look at my teaching material, it's actually pretty easy, bit.ly/iCanTeaching. That's my teaching website, so I will put some updates there, but like I said, on the Slack channel, I'll tell you where to find what. So Slack is like the meta thing where I'll tell you where to find what, right? And even in our class time, I have to decide after spring break how that will work, so you get those information points from the Slack channel. Okay, so for the supervised model, there is a way in which we train and test the model. I'll come to that. For the unsupervised model, I'll give you some examples. And for now, I will leave this alone, reinforcement learning. We'll just call it very advanced machine learning. And what we'll do is at the end of the class, if we have some time, we will delve deeper into some of that, right? So I do not expect you to get much out of this. If you go back and look at my course website, you will see I have some electives, right? We don't have to go into that now, but maybe like sometime 1/3, 2/3 into the class pathway, we might go back and revisit that, and you can tell me which ones we can do, right? So we can pick, this is one potential thing we can delve deeper into. So leaving that aside, let's talk about this supervised learning and unsupervised learning. The important thing to take away from supervised learning is you have the presence of labeled data sets. Okay, does that make sense to you guys? So some people told me you've used statistical models. So a lot of the times, I think the nuances, the differences between statistics and machine learning, like it's pretty like, they kind of entangle into each other's, pathways. But I don't know if I said it right. But one of the things is statistics is an older field, and oftentimes statistics goes with any other field, right? You might want to test your models and do p-value testing, t-testing, etc., right? A lot of the times in statistics, you're testing whether you have the right kind of statistical metrics from some kind of study that you've done. In machine learning, mostly, you have prediction. In machine learning, a lot of the modeling, the goal of the modeling is prediction. So going back to the Portland housing market data set, you are using your modeling to actually predict the price of a house, right? And you might have seen this like many, many times. Y is equal to mx plus b, or a variant of this, right? This is the equation of a line, right? Now, what we do is here, if you can consider y is the price of the house, right? The predicted price, say, right? So let's call it y hat. So again, I think all this terminology is kind of going to be helpful. So y is the actual price of a house, and say, using your model, you predict that the price of the house is y hat. Let me give you an example. Say the actual price of my house is $1 million. That's good, right? In West Lafayette, a $1 million house. But my model, the model that I run, predicts my house to be 900K, right? So 900K would be y hat, which is the price that my model has predicted, and y is $1 million, right? If there is another model that predicts my house price to be $1 million and one, right? So that's closer to $1 million, right? So that is possibly doing better, right? So this is just to give you one assessment of how you would measure how well a model is doing, right? Based on the prediction that the model is making. Again, these words that I'm using, these are standard machine learning lingo, right? And actually, this is really good because I kind of had a tough time. I had a talk last week, and I kind of had to have like some preliminaries inbuilt into my talk because, you know, I wanted to make sure people are getting stuff out of it, right? So it'll be great, you know, next time after my course, it might be easier for you to kind of understand some of the research that we do in our lab, right? So y hat minus y is a measure of how much of an error the model is making, right, in the prediction, right? And then we do something to this to actually make it compatible with the entire modeling process. So let's take a couple of minutes and then stop so that we have this complete bite-sized video. So I told you what we are ultimately optimizing by the modeling process is so that your y hat and y, the difference between the two, is decreased. That is the goal of the modeling process, right? And just to kind of map it back to what I was telling you, so that this is a complete kind of lay of the land of this part of the class, what I'm telling you right now, all of that falls into supervised machine learning. We have not entered into the territory of unsupervised machine learning. By the end of today's lecture, I want you to have some flavor of that. So everything I'm telling you right now, this Portland housing dataset, where you're predicting the price of these houses based on different features, is supervised learning. And features, you guys told me some features, right? For example, square footage, number of bedrooms, number of bathrooms, and I think we also picked the location, right? And then we came to the dimensionality reduction problem. We talked about the kind of, as you keep increasing the number of features, you keep getting a more accurate model, not talking about the nuances of the accuracy, but after a certain point, it might dip, right? It might not dip like this, it might dip like this, it might dip like this, so, but it will dip at some point, right? So I'm gonna actually stop there, just to kind of finish this little part, and then we'll get into the features and a little more about supervised learning. So how about you take a 5 minutes break? Okay.